My examples up to now involved either polynomial or rational functions. Let's finally get out of that trap and get more sophisticated. So here's where my tools of calculus are really going to augment my ability to graph. Now I got a radical expression here, so be aware that I've got a restricted domain. That is to say, the domain's not all real numbers, but all real numbers from -1 on up. Now, to build a sign graph for y, I'll label on a number line the 2 zeros that I do have. To the right of 0, my y values are all positive, but 0 is a linear, 0 is a 0 of a factor raised to an even power, and so I don't get a sign change. I will not check to the left of -1 because that's outside the domain of my function. But now to come up with y prime, let me pull out a nifty piece of scratch paper. And determine what y prime is. So can I stall and just double check my work? I like the first term, I like the second term. Now let me clean it up by combining these two fractions. And build a sign graph for y prime. Now I do have 3 inflection points. Sorry, I meant to say I have 3. Oh my goodness. So I have 3 critical numbers, but keep in mind, it doesn't necessarily subdivide the real number line into 4 subintervals in the sense that I don't care what happens to the left of -1, that's outside the domain of my function. However, to the right of 0, it looks like when I plug a billion in for x, everything's positive. But both 0 and -4/5 are zeros of linear factors raised to an odd power. They act as toggle switches. And again, I don't care what happens on the left-hand side of -1, but this sign graph tells me that the original function y changes from increasing, decreasing, increasing. Whew. Next on my list, let's look at the second derivative function. My goodness, if I have enough room. All right, here I go. So pulling out my second piece of scratch paper, let's differentiate this version of the first derivative function. That means I use a quotient rule. Downstairs times derivative upstairs minus the upstairs times derivative downstairs. Over downstairs squared. Now multiply top and bottom by that radical expression. Does that give me this? And does that give me this? Now here's a 10x squared. That makes it 20x squared. Minus 5x squared is 15x squared. Here's a 10x. Plus 4x is 14x. Doubling gives me 20. Oh, I lost it, sorry. 10x plus 4x is 24x. I still can't do it. 10x plus 4x is 14x. Double that gives you 28x. Take away 4 of the x's from 28 of them, it gives you 24 of them. And then finally, for constants, that gives you a positive 8. So it looks to me like the zeros of y double prime are obtained when this is equal to 0. So solving the quadratic equation, does that tell me this? That gives me the following. So approximately, gosh, I can't read that, negative 1.1 or negative 0.5. Now, of course, negative 1.1 is outside the domain of my function. I'm not going to consider it. However, here is my second derivative function. And building a sine graph, I will only consider the positive component of the square root. And that's going to give me that approximate thing that comes to this. But isn't that going to give you the following? Now, certainly if x is huge, that entire second derivative is going to be positive. But I know that's a 0 of a linear factor if I did factor that. That's raised to an odd power, so it will act as a toggle switch, but it tells me that the graph of the original function up there changed from concave down to concave up about that particular value of x. So now, putting all this together, to sketch the graph of this relatively sophisticated function, which with my tools of pre-calculus, I wouldn't be able to graph without. Now I have two x-intercepts, one here and one at the origin. Now notice how my y values are always strictly positive, except at the intercepts. But I changed from concave up to concave down about a negative x value. But at x equals 0, I changed from, did I say concave? I don't think I said that correctly. I changed from increasing to decreasing about the negative x value, but then changed from decreasing to increasing about the origin. So it looks to me like there's an endpoint to the graph. This local max occurs at an x value of, what did I just say, negative 4/5? I'll leave it to you to find the corresponding y value of plugging that into x here. Looks to me like I also changed concavity, roughly speaking, there. And the concavity changes concave down to concave up at that x value. So this point, this inflection point, has an x coordinate of this. Comma the y value, which I won't waste time computing. Now, if you don't mind me saying, I'm trying to save time. So can you just clean this up completely? Give me an exact value, not an approximation. And that means not using your calculator. So we finally got sophisticated. I was graphing a function that goes beyond my skills of basic algebra or pre-calculus. Let's continue with a few more examples of such.